Okay, we are going live, and I'm not done sharing stuff. So, also ask on Rumble. Can y'all hear me? All right, guys. Another Wednesday technical math science stuff live. Okay, so I'm gonna do that. Anyways, I'm gonna go. I'm just gonna start sharing. I didn't have time to share. Okay, we have 5 people in the chat. Let me know who's in the chat, and then we'll get into this. Initially, I was gonna think about doing how does Faraday cages work. But then I got into a bunch of inertial propulsion stuff in a while, so I'm like, might as well. Okay, loud and clear. Okay, let's go. Okay, also I just want to check how this Rumble's working. I'm going live. Oh, 5 minutes, and I thought I was live. Yeah, this is again, that intro is made by Attila29, epic stuff. Let's see the audios and stuff. No. Yeah, should I make it louder, lower volume? Let me know, guys. Let me know how the volume is. Okay, I'm gonna close this. Okay, it's working. Okay, I'm gonna just share some more stuff here. Okay, this is how I share stuff. Where is the okay, let's go to this is on Gab. Let's see if I have time to share stuff, and then we'll just jump right in. Because I got onto this like this. Okay, I'll just share like on Gab and see what else I can share. Okay, 1 second, guys. We'll just jump in, and yeah. Okay, audio's good. Okay, guys, that is pretty epic. I just want to see how many more we can share. Okay, I'll ignore Facebook one. Okay, I'll just ignore that. Okay. Let's close this. Close this. I'm just gonna close a bunch of stuff. Okay, I'll just close some stuff. I do want to put it on again. Mines. We'll close that. Okay, on InLeo. I'll put on InLeo just because you can do threadcast in there, and I do want to promote the Hive blockchain. All right. So this, like that. Okay. And then I'll do threadcast. Okay, yeah, Attila, let's go. Epic intro as always. So yeah, I put the intro of all these videos on there. Okay, let me just last one, then I'll just get straight to the nitty gritty. Okay, so I'm gonna share this. This is a threadcast, and it's like X Spaces, but it's on the Hive blockchain. Again, all the comments there on blockchain, you get rewarded as well. All right, so there's the thingy. So if you guys figure out how to use the Hive in Leo, it's they don't have a native phone app, but it's pretty good on the browser. You can just go comment here, it will show up. But anyways, we'll keep that. I'm gonna close some stuff. Close stuff. Okay, close stuff. Close this. Okay. All right. Let's go here. All right. So we are back in the show. Okay. The reason I'm doing inertial propulsion one is because yeah, so I was in talks with, again, a friend of John Hutchison, who's researched a lot of inertial propulsion stuff, but yeah, he sort of sent me some stuff, and then I realized yeah, so he asked me, okay, hello dude, okay, rotary, oh, that's him. All right, guys, yeah, so anyways, so then I was asked to review this video, this guy's inertial propulsion device, and then I actually made a video. I actually went over it years ago in 2019, so like literally 6 years ago, but I realized I made some mistakes, but anyways, but nonetheless, it's pretty good stuff here. We'll get to his device here. What is this right thumb? Okay, so here's an inertial device right here, and I'll explain how it works. And so the thing is, yeah, with inertial devices, and also this guy's commenting on inertial devices, I'm gonna send him a link to this stream link. Okay, so we are streaming. They don't put a link right here to it. Like, am I gonna go and copy? Okay, I gotta go to my Telegram. And also, guys, Night of the Revisionist just got deleted from YouTube. So okay, so I'm gonna go right here, and this guy right here. So he says, "Hi MES, can I ask you whether you are still interested in gyro propulsion? It seems like everyone got disinterested in it. Again, you have to. There's a key thing is like the science, and then the applications. Like, there's a million different kinds of applications anyone can do, but the science is pretty much settled that this inertial propulsion is very, very real. So then the question is, well, you guys get in on that. Okay, anyway, so I said, thanks for asking. Yes, I'm still interested, mainly in replicating Eric Lightweight's anti-gravity wheel. So this is the one where he lifts it above. Just because, yeah, so I know lab technician, this is the actually the Alec guy. I was trying to get him on the stream, but he's a bit shy. He's John Hutchison's partner that was literally in the 80s doing the Hutchison effect stuff. So he was the lab technician with John. So they were partners. And note that I think, yeah, so he might be interested in making this anti-gravity wheel. I'm just trying to get in contact with him. I talked to him once in person, but then I've been asking, let's get this going. But yeah, he's still MIA. Oh, no, not MIA, just but aloof. All right. So note that I think gyros have many practical applications in torque/energy over unity production and ether physics, just basically understanding what actual science is. Since atoms, magnets, and so on, may just be ether gyros. Now, so regarding gyro propulsion, precession itself is inertial propulsion. This is the key thing. So I hope everyone firmly grasps this. If people have to grasp that just precession on its own is inertial propulsion, that's it. Like that's the big one. And then you guys can anything else is just like engineering. So again, this one I'll show this. I'll re-emphasize this like a million times. Okay, this is precession is inertial propulsion. It is, in my opinion, also anti-gravity, whatever you want to call it. But anyways, it defies mainstream physics. Just basic precession. There's no mainstream equation that accurately there's no mainstream equation that accurately describes precession. That doesn't ignore that it's inertial propulsion, that the center of mass is moving without reaction. So I'll explain that in a bit. And also for practical propulsion, I think the Hutchison effect is where it's at. And this guy says, yeah, thank you for the reply. I'm also doing some little experiments with gyros. Yeah, I'll check out his channel. Although by now they have yielded inconclusive results, I've never heard about Hutchison effect. Seems to be a bit murkier than Hutchison effect. All right, although I might keep an eye on it. All right, sounds good. I'll see if he has. Does he have experiments here? Does he not have here? Okay, I'll say upload your experiments on your channel. I will check them out. Live stream right now. Okay, well, again, these live streams are basically anyone have questions in the chat, just let me know, and anything math, science related, but then if there's no questions, I just go dive into whatever the main topic is. Now is inertial propulsion. I'll put a link right here. Okay. And I also got here, do you have, so again, these Q&A, these are for both of us. You guys, if you have questions, let me know. Anything science related. Anyways, so this guy doesn't have stuff here. But anyways, let's go back to this device. So this guy here, Harvey Viala. See how to pronounce this one. Where's the...
Fiala.
Fiala. Okay, Harvey Fiala. Okay, let's see how this... Okay, so he's got this device. And I'll explain. Yeah, so I made a mistake. I need to update my anti-gravity notes that I mentioned before. Okay, so here, let's just go all the way back to the beginning. So, let's see when he describes this. Okay. Okay, this guy, it's basically his memoir telling the story of his life, etc. And then he goes over to the presentation he does. My goodness, just go to the presentation. We're here talking about gyros. He's got a bunch of family pics. Okay, there it is. Okay, November 29th, 2011. Eric Lathway, gyro propulsion, Dean system. Okay, anti-gravity device based on inertial propulsion, awarded to Harvey Emmanuel Viala and Downey, California. John Emil Viala and John Arthur Viala. Okay, family fair. The device they say could power flying saucers that have abilities now attributed to UFOs as well as cars. All right, I think it's a bit next level. But by principle, yeah, shows that anti-gravity and so on is real. Let's play this.
11, I obtained 2 patents on inertial propulsion.
Okay. Oh yes, 2 patents. Interesting.
And it's useful for on-orbit station keeping. I just have a humble model of an inertial propulsion system in my garage. It has only one moving part. It works off the Earth's gravitational field.
This is Harvey Fiala and
Okay, going back here. So here's this is the one in the patent, but in the main one. But then he has a slightly different variation. But basically, what happens is, okay, so there is a ramp right here Okay, this motor right here spins this gyro wheel, but also spins the whole axis. All right. So this is just a random, just a bearing. So now there's two zones. One of them here is when it gets off this ramp, it starts processing. And then once it, gets over to, once it goes over to like this side here. So I think this is, there's another lifting here. So there's a bearing right here. This is in direction of this. I'm trying to see how, this one's a bit different than the other one. Anyways, so what ends up happening is, so it's processing this side. No, this one's not processing. No, never mind. So this side right here, when it's going around this side, it's not processing. When it goes over this one, it's processing, and then once it goes to this part here, the back end starts hitting this ramp, and this basically starts rolling. So this starts rolling. So in other words, it's not processing anymore, and it's pushing this forward. But I think this is a reverse one. Okay, this is another bearing here. Yeah, this will be bearing on it anyways. It's a bit complicated.
This is Harvey Fiala and...
Okay, I'll go over his patent. Looks a bit simpler. This is the first image. Okay, so here's the first image in his patent. So his patent is the simplest one. He had a bunch of different stuff. But anyways, here's the patent, is the simplest one. Okay, so this is a support ring. So he has, this one is procession right here. So it processes. So, and it's using, in this case, a right-hand rule. Just use your right, maybe pull out the thingy right here. Okay, so just use your right hand. So this thing is spinning with your thumb out, and it's going to be processing this way. Okay, and then what ends up happening is, this is the part where it's processing. This ramp is downward, so now it's processing. But then right when it goes over to, where's the traction ring? When it goes over to this side, this ramp is a bit higher. So what ends up happening is, I think this pushes it up. This starts supporting it, and then this gets torqued down, and it literally starts rolling here. So then this is, look at the arrow direction. This is going to start rolling this side from here, and this one will be on this side anyways. It'll start rolling, and yeah, so half the side is rolling, half the side is procession. That's all you need to keep in mind. Okay, anyways, play this.
And inertial propulsion.
It turns out that this device is the very, very first approach that controls gravity. Gravity is a downward force, and this converts to a sideways motion. The active mass goes in uniform circular motion on the chassis, but now the chassis is moving under it as a reaction to the motion of the active mass. And inertial propulsion does not use a propellant. It uses energy of a solar cell to turn the rotor. The rotor is balanced to 10 parts in a million.
Okay, and then here's the other part. So this one is a bit different than this patent. So this patent right here, this is what's causing the rolling. In this case, what he has is slightly different. Is that this will spin this wheel, and then this will spin this wheel in the opposite direction. So if this is spinning, let's say my finger, if it's spinning this upwards, this will spin, I think this will spin this, like this way. Now it's no, let me just try to wrap my head around. So this is going to be spinning it. Which way is that spinning? Okay, so this one is spinning this wheel the same direction as this one. But then there should be a offset. I'm trying to
parts in a million, called a super high precision.
Let me just pull out my email. Anyways, I'm trying to wrap my head around this again. These streams are gonna be a bit haphazard. I'm trying to wrap my head around all this because I realize forcing myself to get on this. Okay. Yeah, so this one will spin this way. Did I get the spinning right? Okay, this is the image there. So this is the one that he has. I'm trying to see this. I think I might have made a mistake. Okay, this one will spin. Yeah, no, this one spins in the opposite direction. No, yeah, never mind. Yeah, so this one, this is spinning this way. This will cause this to spin in in the opposite direction. So if you have a bearing, it's a bearing like this. If you're bearing like this, if you spin this one this way, this will spin this way, but it's going to be counterclockwise. So basically, so I'm pretty sure this is going to be spinning opposite. Yeah, so this is going to be opposite of this one. Okay, let's see how this is.
Gyro.
Yeah, because this is connected. Yeah, this is connected to this part right here. So think about it, and I'll show you an experiments. just to illustrate it, peaked experiments. Yeah, so it's counter rotating. One of them rotates one way, the other one rotates the other way. I'm pretty sure. This is what I mean. So if you have one of them spinning this way, and then it hits this one will be forced to spin the opposite direction. So in other words, these are spinning in sync but in opposite directions. This heavy one's actually forcing this one. So again, that's what's happening. This one's gonna spin. It spins this one. So now it's spinning the opposite way, so it can start rolling up the thing. So now this is because you have this setup right here. It's similar to the side here. This one spins, but now from on the opposite side, this one's gonna start rolling this way because this is spinning opposite of the precession direction. All right. Anyways, let's play here.
Gyro. This traction ring is such a high precision device, it's actually a hoop for crocheting. This here is just a brass bar, and this is a 3/16 aluminum tubing and simple wheels. They have a lot of friction. I built what I could. You can see it's on a track that's calibrated. My memory is not that great. That's calibrated either in inches or kilometers or light years. I just forgot. But you can see it moves forward about 2 inches and backward about 1 inch. And that's because for half of the cycle, it's in traction. The other half, it's in precession. This is traction, precession, traction, precession. During traction, it has full inertia. During precession, it has only about half of its inertia. You can see it moves forward maybe 3 inches and back 2 inches or something. And you can see that there's a point of a dead stop. Now, if it had a second rotor, it'd never stop. If you had 4 of them, it'd go 10 feet a minute or something like that. I feel like God put...
Okay. Let's see. Going back to that thing. Yeah, but basically, again, it's really crude, but you see his patent. And here's his patent. Basically, it's going to be processing, and then one of them is rolling. One's processing, one's rolling. And the key part why this works... Okay, and then he has other designs. I'm going to rotate this way. So he has a bunch of other designs that are all similar. He has 2 wheels right here. Again, the whole premise is the same thing. Precession, and then rolling. Yeah, this one is processing. Yeah, notice the counter-rotating wheel. This one's rotating this way. It's going to spin this one on the other direction so that it's rolling, half the rolling, half the precession. Anyways, it does that, and he has a bunch of wheels in his patent. Again, when you're dealing with patents, it's like we're dealing with anything anti-mainstream science. It's not gonna go anywhere. Just get it done, or don't expect it to go, but have a backup plan, because don't put all your eggs into patent basket. Yeah. So here is, and then I think calculate out precession, and then there's a velocity, and then traction propelled, precession, traction, and then and then I think he has some more stuff here. Okay, so basically, and then he has some other crazy ones. Yeah, so here apparently he can fly upwards. All right. So now he's got next level. But yeah, in space would be practical. But again, I think on Earth, precession. I mean, just gyro movement is very limited. But I do think torque over unity, like energy production, and actual physical. I hate how there's all different sizes. Okay, you gotta rotate this way. Okay, let's go back here. Yeah, like this. Okay, this is some other part of the thing. Triaxles. Okay, now we've got a giant one. Alright, so we got infinite patterns. You have some other stuff here. There's another cool stuff. Okay, that's cool. Crew cabin. Flying saucer using an HMT IPD. Okay, interesting. Flying saucer setup. Alright, this guy's got another level. But again, you're dealing with physical spinning things. I think the key is electromagnetism. But anyways, so I want to bring that up because I wrote in my anti-gravity that same video. I actually made some mistakes here. I wrote that it has hindered, and goes. Anyways, I will fix this up on my own time. I don't want to take up your time. So the other part is, again, I want to try this. Okay. Attila says love it. Let's go. Okay, if you go to experiments, I'll go to this one here. So again, the reason all gyros work upon basically precession, and then changes from like stopping precession or speeding it up. That is all gyros are. Again, I can't stress this enough, guys. This is the magical ability of precession. Here is just with a nice block at a horizontal angle. So again, this is, I can't stress enough, this is inertial propulsion. This is in circular motion moving mass. So I'll play this tiny bit of audio. Hi on F YouTube. Oh yeah, guys, I forgot to say that. Let's go on my truth one right here. So here's my Telegram. Okay, so on my Telegram, yeah, so guys, here's 9/11 Revisionist. 9/11 Revisionist was removed from YouTube. Your channel 9/11 Revisionist was following our policy on community guidelines. We removed it to protect our community. Yeah, absolutely wild stuff. If you think you made the wrong call, we'd like to begin review. Yeah, so do a review, but also you have to understand, YouTube is like that. The only reason my channel's up is because I throw in these math and science stuff. So guys, go on this Rumble. And also, what I did before they deleted your YouTube, I actually summarized all your videos. So guys, go on Rumble, and also, this stream is also on Rumble, guys. So no one's chatting in Rumble, but it's also on Rumble. So, yeah, so if you guys want on Rumble as well, if everyone gets deleted, you can always go in the chat on Rumble. And so this is his channel, make sure to subscribe. But also what I did was, so on InLeo, so let's see if anybody commented. Okay, nobody, let's see, nobody in the Threadcast. Okay, nobody in the Threadcast. But anyways, so for what I actually did last week or 2 weeks ago, oh, I got 3 referrals. Let's go. McGew 1990s in there. Let's go. And Tom Power. Okay, we got a bunch of people in there. Let's go. All right. So what happens is, yeah. So what I did was, if I go all the way down, I think I had a Threadcast somewhere, and I did it for. I basically summarized all of 9/11 Revisionist YouTube videos, so they're all there, at least in the AI. So that's the thing. The key part is make sure to get these documented forever. Okay, where did I put it? Okay, quick InLeo threads. I think this was it. Okay, this was latest. No, this was let's go to oldest. What was the oldest one? Go. This was yeah, MES truth. And I think once I did all those, I did the 9/11 Revisionist next. So I'll check what I did. Okay, and then so I did these. I summarized all my MES truth videos, and then I summarized. Oh, go. Yeah, these ones are all yours. Yeah, so these are, you can see all the video unavailable. These are all 9/11 Revisionists. So you can click here. Let's see the video here. Quick summary. So these are at least on the blockchain. So the summary of them are on the blockchain. So inconvenient truth behind 9/11 attacks, calls for accountability, new investigations. As the discussions surrounding 9/11 continue to evolve, continuous call for action, errors in reporting, whistleblowers, revelations. Yeah, it's talking about yeah, Judy Wood, whistleblower, and so on. Role of defense contractors. So it literally has it here. Companies like Applied Research Associates and Science Applications International (SIC) have links to advanced weapons and so on. So, anyways, so I summarized all your videos. So again, your videos are gone. So again, that's why I will say Hive blockchain. Your summaries are gone, but your summary. I mean, your videos are gone, but your summaries live forever, and that's gonna be on the AI, and so on. So again. You saw that, and now the next one I'm doing is all of Martin Fleisch memorial projects and Bob Greener's videos. So again, because I think he does cover a lot of groundbreaking info. So, but I do want to summarize it because it's it's easier to ask the AI to simplify it than it just simplify it, because Bob Greener says a whole bunch of stuff, but he's a bit over my head sometimes. Because yeah, he has a lot of info, but again, it's like connecting all the points together, and also anyways. Okay, Roadrunner says, Matthews, you need to do a strategy session with you sometime to work past all the censorship. Even 9/11 planes are sort of stuffed now with BitChute in the UK. Oh, really? In the UK they do that? Is there something in Richard? I just told him if you would just upload the trailers on YouTube, then link to his Rumble. Okay, Knickerbacker's on. Okay, guys, we have Knickerbacker. Yeah, but the thing is, you have to realize, I told who? It told me? Oh yeah, yeah, that is true. What you could do is you could upload trailers on YouTube and then link to Rumble. Yeah, that's a good way. I think that's what like Andrew Kaufman and like Sam Bailey, Dr. Sam Bailey do, for their videos, COVID stuff. But again, yeah, you could do stuff like that if you're gonna get removed. But again, the other strategy is post science related stuff. But also, yeah, there's censorship stuff. Yeah, definitely. Get on the Hive blockchain ASAP. Like I don't know how to stress enough. So again, I was actually trending for a month, like 8 years ago. That was like I was like the highest viewed post in the month. It was my 9/11 research playlist. Okay, why is there sound here? I should have turned all these off. Okay, let's see what this is. Just 1 second. I'm just gonna turn my sound off. Okay. So, anyways, so this stuff right here is no one's gonna remove these stuff. At least the text, the metadata, and all that, and the images. Well, the images can be removed, but not the images aren't on the blockchain yet, but they're good enough. They're IPFS. Mark Holland doing trailers. He just uploaded a video, by that way. Okay, interesting. Yeah, let's check out Mark Holland's. Yeah, and also the other part here, the notes. The notes is what I think is super important because all the links are there and so on. So all this text and stuff, it's on a blockchain. It's not going to get removed anywhere. And also 3Speak is building a decentralized video storage, so people are like incentivized to. Soon there'll be a token out rolling. But anyways, all the metadata is on the Hive blockchain. But now these ones are all being stored on random people's servers as opposed to one major server. So again, there's drawbacks and there's good stuff. So the drawbacks are let's see this one right here. So I upload all these stuff as well. Okay, so I try to upload all my videos. The drawbacks is that the developers are there's less development like at the initial point because there's less money like to focus on one. There's no central company. But the positive side is in the long run, as more and more people use it, the development will be basically anyone can develop on it for free. Well, basically anyone can develop on it and start growing bigger and bigger. Similar to Bitcoin. Bitcoin was slow, and then all of a sudden, there's like the most powerful computing network in the world. Yeah, just because it uses the most. It uses so just to compare it. So Bitcoin is decentralized, and let's just see Bitcoin computing power vs Google, etc. So you can see versus Google, who has more computing power. Tech giants versus Bitcoin network. Let's see right here, just in terms of computing, because all they do is mine computers, mine calculations nonstop. Is there a chart? Like, why is there text? Like, nobody wants to read text. I just want to give a chart right here. I think this is okay. Bitcoin computing. Let's go. Yeah, or here's a just good example. So Bitcoin consumes a similar amount of power to the Netherlands. So there's Bitcoin alone. So here's the data centers all worldwide. This is as of 2019. It's probably surpassed all of them. Data centers worldwide, 199 annual. This is trillion watts at watt hours. 199. Bitcoin's above that. Bitcoin's more than Netherlands, more than Chile, more than Google. It's 12.4, and then more than So basically 10x Google is Bitcoin, and that's 2019. And then each time grows bigger and bigger and bigger. So again, and I think similar with 3Speak, but again, 3Speak again is censorship resistant. I use it as backup for everything, so I put all my stuff there so that at least I'll know that they'll be here eventually. Because again, there's developer issues, but nonetheless, pretty good. Because Rumble also has their own guidelines and so on. That eventually they'll become like YouTube, and you can see that right here. Rumble. I think Rumble. What is it? Disclaimer, or I think they said something about if you can't criticize Israel for some reason. Let's see, I think they mentioned earlier. Rumble censorship. Okay, yeah, it was somewhere there. I forgot. But anyways, terms. I think I posted. Yeah. So this one right here, Rumble terms of service. Let's see here. Content that promotes and supports or incites violence or unlawful acts. So if something unlawful, like you can't, they can remove it. Okay, this one promotes or supports entities and or persons designated by either Canadian or United States person as terrorists or terrorist organizations. All right. So then, content or material promoting or providing instructional information about illegal activities. Okay, so you can't provide instructional stuff about an illegal ones, like how to get away from the vax. I'm gonna just drink some coffee right here. Okay, and then also here, there's also decimating personal information, doxing, and so on. Okay, any content or material that contains links to another website where any of the above described prohibited content or material is accessible. So if you put a trailer and put a link to another place, It's pretty interesting. You can't do that. And I think that there's more stuff here. Okay, content or material that is grossly offensive to the online community, including but not limited to racism, anti-Semitism, and hatred. So they also have that term as well. So you can't have yeah, and also here's top owners of Rumble stocks back then. Vanguard, again, the usual BlackRock, 1.1%. Still tiny, but again, BlackRock invests in everybody. All right, so there's the post, I think. And let's go back to the terms and conditions. Let's see, I think Semitism. So they always, yeah, they always put Semitism. It's like they know how they do the script. But again, you know my side. I think it's all scripted. The pro-Semitism and anti-Semitism is all scripted, so that everybody has a person or people to blame, as opposed to themselves. Okay. Anyways, I just want to check 9/11 planes research. Okay, so guys, again, these Q&As, you can ask me questions and so on. 9/11 planes research. And the important thing is, yeah, YouTube Rumble's gone too. But again, it's not necessarily, yeah. That's how the things we are working with is. But also, people are like, a lot of people have different opinions and so on. So so you'll know where they are. So YouTube is important for getting normies in there. So for example, if I post 9/11 stuff on BitChute, it's like, yeah, I'm preaching to choir, except that there's a whole bunch of disinfo agents at BitChute and flat earthers. And so it's like, it's weird. So it's a lot of disinfo agents, but then on YouTube, it's a bunch of normies. So you're dealing with normies versus conspiracy peeps. So again, but there's more normies in the world than there are conspiracy peeps. I hate, where's 9/11 planes research? A plane or 911. Why isn't it finding it? Just search it on YouTube. My goodness. Okay, YouTube search is literally the worst. Like, just 9/11 planes research. There it is. Okay. Let's see his trailer. I think he made a trailer. When did he make a trailer? Anyways, I don't see a trailer. This is 8 minutes. Can't be a trailer. Oh, 3 are video update, recent developments with BitChute and more. What is the development with BitChute?
There. I just thought I'd do.
Oh, okay.
The videos on there. He's no longer available in the United Kingdom.
Oh, there's no more UK? Holy. No, I never heard about this. This is absolutely wild. This is UK is so bad. All right, yeah, I didn't realize this. This is like, but you can't even go on YouTube. This is the issue with centralized entities. They can go after centralized entities. Similar even Gap, they can go after and so on. But the key is you remove like your own power by going on decentralized. So basically, the decentralized system can do whatever it wants. Well, it can exist similar to Hive. So like Attila, yeah. So the 29,000 tons of thermite says. He also told me that in Iran you can't use crypto or different sites are banned or whatnot. But the thing is, on Hive nobody can take it away. And also similar to Dr. Nagas on Substack. The government or the court order literally had to remove his. I think they had to redact. Oh yeah. Trailers. You upload summary on YouTube, then links to yeah. That's a good way too. Okay, so this is what the Canadian government or the court order did to Dr. Daniel Nagas. They forced him to not mention anything in the social media. So they literally had he had to change up his headline here. So the bulk of his article has been redacted by warrantless court order. So this article literally was removed. Like, think about that. Okay, this is the bulk of and also where's the censored one? Where's censored? I think he has. My Substack will be censored in 5 days, and then the court order until further order of the court. The respondent immediately and in any event within 5 days of being served with a copy of this order, immediately delete or remove all statements and content which he has published or caused to be published in any online form, including any social media platform which contain direct or indirect reference to, and blah blah blah. So, and it even says here, respondent is prohibited on interim basis from publishing or causing to publish any statements or content in any online form, including social media, which contain direct or indirect reference to, blah, blah, directly or indirectly having to, blah, blah, blah. Okay, so again, that's absolutely wild stuff here. Okay, Timothy Sullivan's house, let's go. And that's why on Hive, you post it, it will always be there, even if you, like, edit your thingy, the previous versions are always there. So I think, to give you an example, I think it's like, I've never checked, like, specifically. So let's see how this would work. There should be a few previous versions. So do they have that? Yeah. So right here. So here, let's say I edited this one, or this one's a better one. So this one here, I always edit the image there. So let's say you can always click here and click view previous versions, and then you can see the version history a day ago, and you can see all the changes and with the code there, and so on. There's also the metadata and so on. Yeah. Oh no, that was my metadata. Yeah, I think that was my stuff there. But anyways. So Substack is not blocked in Iran. That means Substack has to deal with them. Oh yeah, so that's interesting. So Substack's not. What is blocked in Iran? Hey, Timmy Sullivan, 9/11 been banned again. Yeah, on 9/11 revisionist is banned on YouTube again. So now his like 5th channel is gone. And I do want to check one thing. Okay, nobody commented here, but I think I might have broken a record for this again. Okay, Gary Jackson, I'm here late as usual. Yeah, all right. I heard you filed a report. Yeah, so you sent me that thing that you filed a report for filed a lawsuit for assault by that county school board. And also here, guys, I just broke another. I also was number 1 on the in Leo summaries. Again, epic stuff. Always taking over the game. Okay, there's any comments right here. Rethread. All right. Alright, so I'm going to close this part here. I'm going to close this. Alright, yeah, anyways, let's go back to that gyro stuff. Again, all gyros, this guy's entire apparatus and so on, it all stems from, there's a design. This is the exact design that this guy was doing. Anyways, guys, today, math Q&A, so you guys ask me any math science related stuff, and I'll answer them, but if no questions, I'll just dive into whatever I was working on. Today was inertial propulsion. So this guy's experiment here, yeah, so the wheel spins opposite direction. And yeah, so basically this one half is processing, half is rolling. So again, when it's processing, gyros don't have their usual mass. Okay, I can't stress this enough. I can't stress this enough. I want if you guys like, even if you're in Iran, yeah, go to a professor and show them this. Tell them, why aren't you talking about this? This is like the simplest reality-defying science out there in the world. Is this stuff right here. It's so simple. And then, meanwhile, universities talking about black holes, quantum mechanics, like time particles going back and forward in time. Oh my god, gyroscope's literally defying all mainstream physics. Right here, this image right here is impossible according to mainstream physics. And I still not to stress this. I think I might do like a full stream where I just have this image right here and just laugh even you guys in the chat. Does anyone grasp this? Again, the reason I grasp it is I dealt with this in school back then. Well, just a bit in mechanics. So the center of mass is processing without any horizontal forces. Okay. It's moving. The center mass is moving. Reactionless. This is reactionless. Inertial propulsion is anti-gravity. This is literally anything and everything you want, all right here. And I haven't even talked about gyros rising on its own, or that it's all torque over unity. Like, all this is over unity. I know that Leonardo da Vinci was frequently trying to devise a perpetual motion machine, and that rotary motion fascinated him, and that he even put it in architecture designs. Anything for you there? Yeah, I looked at that, but again, I think getting anything practical out of just a gyroscope flying, that's not gonna happen, in my opinion. But yeah, but the actual thing I'm trying to say is that this motion right here shouldn't happen. And to illustrate that it shouldn't happen, if you go, it's not even on Wikipedia. So precession. So it's like no one. It's like, I don't know how to stress it enough. It's like dealing with okay, this right here. This motion on Wikipedia, this is an illusion. The reason is they're not telling you what's happening at the bottom. This is an impossibility in mainstream physics. But what they're doing is they're assuming that the base is fixed. Okay? They're assuming that, so they don't need to care about friction or anything. But the thing is, this does it with it, if this is fixed or not. It's the same thing. And I'll explain here. So I definitely want to stress this. I can't stress enough. I have to like literally tell you guys a million times full. Okay, I'll edit this one later. Okay, I'm gonna close this. I'll do editing on that. I made an error on the other one before, but I'll go over Cambridge. So, and it's not just mainstream physicists. It's like everyone, alt sciences, actual people that research this forever. And it's like the only person that I knew understood it right away is Eric Laithwaite understood it. Okay, Eric Laithwaite grasped it, but nobody was listening to what he's saying. Like no one. Like I don't understand. It's like I think half the world's conspiracy is done like it's not even like it's just that people just aren't thinking. Okay, I want to go to okay before we go to the Cambridge. Okay, so here's the thingy. Okay, so Eric Laithwaite right here, he's demonstrated it right here, but no one is listening to him. Okay, recap Eric Laithwaite's demonstration of gyroscope processing with 0 centripetal force. Well, not so 0, but just like way less than expected. Okay, Eric Laithwaite demonstrated that a simple toy gyroscope had always defined mainstream physics, but only if we had the eyes to see. Okay, so this gyroscope right here, just look at this, and I'll show you what Cambridge University like did a hit piece on him, trying to debunk it. Okay. So I think it was at the which minute? At the 23-minute mark. So 23.
Making a flywheel. So there it is. This is the modern high standard of living. This is an old-fashioned gyro about 30, 40, 50 years ago. We have some gyros here today that are 100 years old. So here's a thought. This thing has been with us for 100 years, and we haven't noticed those things which we might have noticed.
Okay, so hear what he just said. He says, this gyro is there for 100 years, but we haven't noticed what those things we might have noticed. In other words, no one is literally listening to what he's saying. This is literally anti-gravity, anti-inertia, anti-mass. Again, understanding this is, in my opinion, more important than, well, again, all the black hole stuff. The reason all this, like, mainstream science seems all like, woohoo, like, you got black holes, you got the speed of light is fixed, space and time are merged and together. I'm like, what about a gyroscope? How does that work? Or not just how to work, but like, why does it defy all equations of mainstream physics? So again, go back here. Listen to what he's saying.
100 years. Our thing has been with us for 100 years, and we haven't noticed those things which we might have noticed. A tower on ice.
Okay, so it's processing. It's on ice here, and I'll show you what the Cambridge University hit piece did on him. So this Eiffel Tower is not falling over. All the mass is like almost all of the mass is near the axle. Like it's in the wheel. Okay, so basically the center of mass is moving around this, and it's not falling over. Okay. Okay, so and that thing's not falling over, and it's not sliding over, and so on. And then to give you an example, okay, if you have a mass that's going in a rotation like that, it has a lot of momentum without if it's not spinning. So I'll go over to this one, hammer throw, Olympics. Okay, so remember that gyro is processing on a little tiny Eiffel Tower. So this is hammer throw, going pretty much like, yeah, this is going faster around, but the idea is the same. Let's go play here. Let's see how this one is. But the other mass is really big. So
12 men were competing.
they're probably equivalent in terms of to scale, like the amount of momentum being pushed. So here's this guy's, I think, yeah, gets a hammer throw world or record, or just gets gold medal. Let's play this one here. Okay, look at how much momentum is being pushed outward.
World champion in this event and was on good form, having thrown the furthest in qualification. The first.
Okay, and it's a tiny, relatively tiny weight compared to the gyro.
Throw.
And it launched out.
And it was huge.
Okay, notice that it launched out. Okay, notice the gyro's not launching out. The gyro's not launching out. Okay, does anybody grasp this yet? Okay, where's that gyro? Okay, this one here. The gyro's not launching out. It's just going in a circle. Okay. Okay, so now let's look at Cambridge, what they said. So and then to give you an example, this is a 312 gram gyroscope processing about a 1 gram pedestal. Is absolutely irrefutable proof that a gyroscope processes with 0 or near 0 centripetal force, even without the ice. Again, it's on ice on an ice tray, and there's a little toy Eiffel Tower. So again, to illustrate this, 312 grams versus 1 gram. 312, 1 gram. 312, 1 gram. This is the equivalent of a 3,000 pound gyroscope processing about a 10 pound ladder. So imagine you had this car spinning. If you had this car spinning, it can go process around this without knocking over the ladder, assuming the ladder can hold up that mass. Okay. Timothy Sullivan. I suspect the hierarchy of scientific activity is mostly controlled by the unseen power structure. Look at the Penrose family. Interesting. Yeah, Penrose is very interesting. Yeah, that was the that Penrose tile guy. I was about to buy one on magnetic one on Etsy, but then they said that it didn't arrive, and I'm like, okay, I'll save myself $100. But it's pretty cool. Penrose stuff is pretty cool. But yeah, there is definitely the power structure is, but also it's like there's definitely some voodoo magic going on over there. It's like why can't anyone just see this? Like it's just so simple. All right, so here's what I mean. If you had a car spinning in a giant gyro, it will process around a 10 pound. Okay. And now this is Emma Wilson's from Cambridge University. Attempt to debunk the undebunkable gyroscopes processed with zero centripetal force or near zero. So if you go to Cambridge, I think they might have removed their website or something. So this is Cambridge University trying to debunk Eric Laithwaite's gyro. So in processing of a toy gyroscope on ice. In his video, Eric Laithwaite places a toy gyroscope on a tower of ice. It is intended that the ice will provide a frictionless surface. That's not the reason. It's on ice is low friction, but also that the tower is tiny. It can be seen that precession occurs as before with the gyroscope processing around tower. Laithwaite claims this shows that the gyroscope appears to exhibit no centripetal force. It does. It's like literally almost zero. It can be seen that the tower's legs would dig in. So the reason they're saying is that the legs dig into the ice, meaning the assumption of frictionless surface is not valid. Again, he's not saying that. He's saying it's very little friction, but also the pedestal is tiny. The actual Eiffel Tower toy is tiny. It's 1 gram. It's not valid yet. Therefore, Laithwaite's claims that the gyroscope appears to exhibit no centripetal force is also invalid. This is like whoever wrote this is definitely a lying psychopath. And then they show videos not there anymore. And again, here is the demonstration here. So the center mass, they're saying the center mass is somewhere around here, but it's actually closer to the wheel because the wheel is most of the mass. So the air table provides a flat frictionless surface. Therefore, there can be no net lateral force acting upon assembly. So here's what should be happening using an air table. So basically, if you have this processing, the center mass would be around here. So there's no lateral forces. The center mass of the system must be fixed here. And also their gyroscope setup is so bad. They had like this super heavy thingy, and it's very hard to see what in the world's going on here. And the actual base and so on is like heavier. It's like I think it's probably heavier than the actual gyro. Anyways, the videos are not there. You have to watch my video played. But here's mainstream physics. The key part is this is mainstream physics. If you had a frictionless or near frictionless, or in another case, a tiny Eiffel Tower, which should have been knocked over, okay, this is no lateral forces, so the center of mass of the system must stay affixed above this point. Okay, this is Cambridge, absolute lying, and then they're talking about a bunch of precession, what causes it and so on, but they're ignoring that the mass is gone. All right, anyway, so they're saying precession is around this area. And it's like, and it took, and this was Eric Laithwaite in like 1980s or something. Or no, this was actually, never mind, this was even earlier than that. This is in 1974. So it took how many more years, 2019, until I show up with the simplest experiment of all time. So add, how many years? Add 30 years, that'll be 2004, add another 20, so 50 minus, minus 5. So it took 45 years later before someone just shows, okay, we'll stick with these lying psychopaths stance that okay needs a frictionless surface. Okay, I'm like, oh right, and that his tiny Eiffel Tower was digging into the ice. Okay, we'll remove the digging. So here's removing the digging. It took another 45 years until I just show up and say, okay, here we'll have a little ice block, and it's very low friction. Here's a gyro, much heavier than this, and it's very low friction, and it's processing around, and yeah, the center of mass is over here. The center of mass is inertially propulsing, so it's processing without the expected centrifugal force, and it's no fact. The fact that when it's almost done spinning, it goes up is crazy. Yeah. They're going up. Basically, I'll show you. I'll show you to make it go fast. This one I just made it really horizontal, so it's not gonna rise. But the fact that it's not falling, okay, guys, it's not necessarily rising. It's anti-gravity right here. It's anti-gravity. It's not falling. It's also the mass is not there anymore. The mass is acting as over here. The mass is shifted over here according to mainstream, or it's like floating in an ether. So that's what I actually think is happening. It's some ether jumbo. Okay, so and then once it loses its spin speed, it regains its mass. So what happens when it? I'll just fast forward. So what happens when it regains its spin speed? And you can see it's rising a tiny bit in this case. This one I made it flat just to illustrate. Just show the center of mass super far out. To rise, you need to make it a bit higher at the starting point. Yeah, and now watch what happens, and it's gonna start gaining its mass. Yeah, and now it's behaving similar to this Cambridge. Yeah, stuff. Now it's behaving like this once it's losing all its mass. So it's like Cambridge is like literally, I don't know how to say it. It's like pure evil. It's just absolute evil stuff. Like okay, and this is the thing. So like the mainstream, most of mainstream of like all of mainstream reality focuses on perception. Perception is how could the universities overlook such a tiny thing? So then if I say, hey, look, this gyroscope is anti-gravity, anti-inertia, anti-mass, everyone will laugh at me like, hey, what are you, a kook? like, what? Like, look at it. Because like, why would all the universities and trillions of dollars be wrong? Okay. So again, it's all perception. Perception runs the world, not actual reality. Perception. And this one is still, it still has a lot of its mass not there, but eventually it will go away. I think I put a bit higher. Or there. Okay, it's still, yeah. Now it's chasing, and now it's chasing around. It's still not fully, yeah. But now the ice block's moving away. So ice block only moves when the spin speed is almost gone. So now it's moving away. Okay, I want to illustrate that, and also to illustrate how Veritasium, the big giant YouTuber, like one of the biggest on YouTube. So again, just enough. This is inertial propulsion. Is precession alone is inertial propulsion. Okay, going back into this part here, I want to show. Okay, this was this is when I was like probably yeah. So again, gyroscopes make me more mad than 9/11. 9/11 is like, oh yeah, obviously. Okay, so let's say you find out they have advanced tech and all that stuff, and you're like, yeah, you're pretty mad and so on. But I'm like, this one is so simple. There's no politics involved. It's just a little gyroscope. There's nothing. There's no war involved. It's literally just a gyroscope. Yet the cover up is as big as 9/11. Well, no, actually, no, not as big because nobody's actually looking at it. It's just me. It's just me. It's like me and Eric Lathwaite. It's like if Eric Lathwaite had someone like me telling him, like even his students. I actually met someone that who had a PhD whose supervisor was actually Eric Lathwaite's student or knew him. So that'd be pretty wild. But again, it's like nobody, even if you go to universities, like does anybody understand it? Okay, anyways, so now this is an anti-gravity wheel, which I hope to replicate, but with like a 100-pound wheel, but I need to wear like a full body mask, body armor, so I don't get blown up. So before we get to that, so here's the anti-gravity one right here. I go back into, okay, so we covered this one. I'm gonna go over to. I'm gonna close some stuff. Okay, this one's pretty cool. Yeah, I'll just close this. We pretty much drove into it, and because I messaged. This is Alec. Alec is actually the John Hodgson's lab technician. Okay, in the 1980s, they were partnered with when they were doing all the experiments. So he witnessed a lot of these experiments, like literally hours and hours. He was with John. Okay, so that's that part. To getting other emails. Okay, I'm gonna move this above here. Or actually, I'll just close it. If you guys email me stuff, let me know, or you can post it on the Telegram. Okay, so I'm gonna close these. So again, that whole point is gyros precess without inertia, and then all of a sudden, if you stop it by rolling, you can bring that inertia back, and so on. And this one can also rise, and so on. Actually, yeah. And he also demonstrated here where it can't crack this when it's precessing. Okay, anyways, so we got that part. I just want to keep going. Okay, this is absolutely wild. UK regulation. I will post that soon. I'll post this right here. So guys, 4 links that's related to the stream or that was during the stream. I'll just put everything in this comment. Leave a comment. Absolutely wild stuff here. Okay, yes, this is absolutely wild stuff there. Okay, and what else? What was this thingy? Yeah, so on Hive, you can see all the versions. So again, we'll definitely need a, 911 versions if you're still in here. We'll definitely need a walkthrough on it. Okay, so anyways, there's a hammer throw. That's actual inertia. And now I just want to keep going into, let's see, which was the anti-gravity now. Anti-gravity video series on, put on this as well. Okay, so now, this one is I want to replicate. This part right here. And I'll explain how this is covered up. This is 1983. Absolutely, the masses will refer to the authorities in a hierarchy, and all the positions and rewards go to those who respect the structure as if the power is divine, although academia is cut. Yeah, again, it's like all of life. All of life is like that. It's like everything's a fractal of it. Every family and household's like that. Like the average family household is no different than the average government. That's another thing is that people have to grasp. Okay, it's like to remove the tyranny outside, you got to remove it inside. Okay, like think about very closely if you're a tyranny to your own family, and so on. If you're in any way tyrannical, meaning, are you allowing free thought and free actions? Loose from the church, royal power, and so on. Yeah, but again, everything is in any society, you're gonna have structures where, again, people want control over others because they think they know what's right. Okay, let's play this right here. And then eventually it leads to like the current control, which is psychopaths will literally like know lying is bad, but believe that lying can be good if the has a noble purpose at the end. So it's like so again, that's how these people run the world with. Okay, anyways, so here's a 40-pound wheel, but he also did it with a 51, and apparently he also used it like lifted with a finger before. So anyways, so here's a gyro wheel. First I want to illustrate right here. So he has trouble picking up with two hands and using a scale right here.
That lifting it is quite an effort. It weighs about 40 pounds and I can't lift it any higher than that.
So he can't lift it any higher than that with two hands. Think about it. And this guy's like 60 years old, 50, 60 years old. Yeah.
Without a lot of strain. So now we'll spin it up to 2,500 revs a minute. At which point it becomes a live thing. Then I shall lift it 5 feet in 3 seconds by going round in a big circle.
And he's spinning it with no safety gear or glasses or anything, and he's an old guy. Because if that just touches the ground, it's going to start spinning and like destroying the whole place. Restless Native, bless up man in chat. Restless Native is in the house. Okay, I'll spin this up.
Whilst I'm doing it, I shall talk to you. So you can tell from my voice if I'm not under any stress at any time. And the minute I shall let go with my left hand, and holding this remote end of the shaft only, I shall lift the wheel through 5 feet, all on its own with no effort on my part. All I do is apparently just to steer it along a path that it's already decided it would like to go.
Alright, so he's lifting it with no effort, okay? Yep, nothing more tyrannical than most families, yeah, that is true. Rudolf Steiner met with Tesla many times. Steiner had also had other machines such as the Schrader machine, which some information can be found online. Interesting. Interesting indeed. Okay, so again, he's lifting it, and he's, again, no effort, and now look at Veritasium. Okay, here's Veritasium, 17.6 million views 11 years ago. They had to do this stuff. And look, first he was doing it, they're explaining it. They're saying... On
the scale, the wheel is spinning. It still weighs 91 kilograms. You made the prediction. Let's see what happens when I throw it up over my head. In 3, 2, 1...
All right. So, anyways, it's a lot of this stuff. They're saying, oh, there's no weight loss or whatnot. There's an issue, first of all, with that, but also there shouldn't be any expected weight loss difference. But also, mainstream physics, there should be a weight loss reading change whenever the center of mass moves. So again, so he's he's just this entire thing is propaganda designed to fool the average person. So again, none of this is needed. because there's nothing spectacular expected from anything moving that slowly up or down. Okay, nothing is expected with this tiny imperfect weight scale. If you're standing on there, just you moving your knees back and forth will shake it. So it's like it doesn't mean anything. All these results mean nothing. The up and down, yeah, when the mass is going up, is similar to bending your knees up and down. That's pretty much it. So again, so now listen what he says. Look what he says. They explained when he says it. Okay, so he's saying that this guy was wrong, but then he lies about what actually happened.
Isn't he?
Watch it. This is trick.
Eric Laithwaite. Listen to how he describes it.
So here goes 40 pounds of wheel as light as a feather. This is not a conjuring trick. This is a fact of science.
He sure makes it look easy, doesn't he?
Watch it again carefully. A fact about a spinning wheel that so far everyone has missed.
Professor Laithwaite claimed the gyroscope's properties couldn't be fully explained by Newton's laws of motion.
Yes, that's like irrefutable.
I disagree. But in order to understand why the wheel feels so light, we first have to consider why it feels heavy when it's not spinning.
Okay, so he's lifting up with 2 hands away from the axis. So again, this is what I want to stress it up, okay? Eric Laithwaite couldn't lift it high with vertical. Again, where's the let's go back here. Let's go back here. Okay. Oh, here's another. This is another video. This one is he lifting with 1 finger. This one is I think 15 pounds or something. I think 15 pounds or 15 to 25 pounds wheels. Yeah, I think it's 25 pounds. He has his pinky finger lifting this one. All right. Yes, should weigh about 24 pounds. Yes, about 24 pounds. Anyways. Okay, so Eric Laithwaite. So notice right here, he's lifting it like this, and now he's putting up some fake sign saying, "Oh, the torque is high here."
Two-handed, that's as far down the shaft as you can hold it? Yep.
Holding the shaft horizontally, you clearly need to provide an upward force equal to the downward weight of the wheel.
Okay, so that's not what Eric Laithwaite was doing. It's like, does anybody watch the actual video? And then he's saying, look, I pushed it. Eric Laithwaite literally says he's guiding it by moving it over. Anyways, so he's just force processing it, and he literally said that Eric Laithwaite did a trick by pushing it. Anyways, where did Eric Laithwaite show that thingy? Where did I had the image. Where's the image? I put the image. Why is the image gone? Okay. Where did the image go? Okay. Let's see. I think I put it way up here. Where did it go? Okay. This is all the design here. I could have sworn I had it. Okay. This is. Oh yeah. I did put an image. Unless there's a second image. Where is my image? Anti-gravity wheel. Where's Eric Laithwaite lifts the okay. I could have had it somewhere here. I don't know. Okay, this was here again. I made a whole section on clearing Eric Laithwaite's name from slander and ignorance. The entire thing. But why didn't I put an image there? I think I could have sworn I had an image. I made a comparison. Them comparing the two. Oh yeah. Anyways, so here it is. So this is what Eric Laithwaite was shown. He can't lift it with 2 hands vertical, and then this guy's clowning by using the torque is high there. So it's like, what? That's not the same thing. All right. So anyways, and instead of trying to like take it to an extreme, take it to let's say 100 pounds, or use the same one, use 1 finger or whatnot. So anyways, the gyro lifts without the expected. It's lifting on its own. And the other part is that whole weight scale thingy is mumbo jumbo. If you illustrate right here, anyways, if you go further, it has this guy here. I definitely think he's like a high-level Mason, and that's talking nonsense. And he also talks about nonsense over here. Again, I highly recommend watching my thingy. So he goes over here.
Dramatically.
I'll show you right. I'll show you.
Oh, it goes down.
Slide the position and it falls.
But the weight doesn't change.
Okay.
Vary the position and it rises.
Okay, so this right here, he's saying hurry the precession and it rises, but the weight doesn't change. But again, what he just said, the reason that the weight didn't change is because the weight scale in this particular setup is not sensitive enough. As I was giving an example.
Process faster, it lifts up.
Hurry the position and it rises.
But but the weight doesn't change.
Okay, this is it's moving too slowly for weight to change on the weight scale. But the thing is, but mainstream physics, if your center mass moving, the only way to move is if you have a force upwards. So the center mass moved upwards. And anyways, for example, jumping, you have a 1,400 pound force, pounds of force on the ground there. And you can also make a mass moving just by wobbling back and forth. You'll see weight moving. And I think they also show it. He also moves here later.
Similarly, if you slow the precession of a gyroscope, it goes down.
Slide the precession and it falls.
Okay, anyways, so again, just a bunch of weird lies. So these guys, I definitely, I think this guy's one of the guys who wrote the articles on fake science here. And I even wrote it right here. Yeah, I even wrote here 7 years ago, such an absolutely disgusting, pathetic, quote, explanation or more accurate cover-up of the existence of anti-gravity. And even more disgusting is this pathetic channel's outright slander of Professor Eric Lightweight. He is literally carrying heavy weight while it processes while it weighs like nothing. Veritasium is an absolute disgrace to humanity. Okay, there it is. Let's go. This guy says, okay, so we got it. My comment is still there 7 years ago. This was absolutely, like, ridiculous. Also, 29,000 tons of thermite says Veritasium. It's even deeper than that, okay? Okay, and also here, St. David says, bless up, man in chat. Never forget 9/11 Moonchild, heard it here first. Let's go. Okay, guys, you guys did hear it here first. The Moonchild stuff, I called it. The whole fake Trump is fake assassination, that's absolutely wild. Okay, so now if you go here, now this stuff gets a bit deeper, okay? So, 29 tons of thermite says Veritasium. And, okay, you will not believe this, okay? PhD. You will not believe this. Okay, so his life story. What does he look like right now? So if you go to his PhD, he's wearing all black. He looks like a man in black, wearing a suit. It's my life story. Okay, let's just see what was his PhD in. Anyone make a guess? Guess his PhD thesis. Guess what? Yeah, guess his PhD. What it was on. Everybody guess. I will give you guys a few seconds to guess before I open the video. Okay, let me know. Guess in the chat what you guys think. This guy that covers up 9/11. I mean, covers up also 9/11 by proxy, but anti-gravity, Eric Lightweight's thingy, and he's doing all these videos and so on. But what is he? Physical exercise, exorcist? No, exorcist or exercise? No. This is you will not believe it. Look what he's wearing. He's wearing all black, like a man in black. Okay, I will play. Okay, so arts and culture. No, this guy's a smart guy. Okay, he's not. They don't have dumb guys. They don't have dumb guys. Covering up Eric Lightweight stuff. It's a smart guy. He's a smart guy.
But
okay.
Failing at that.
I will. I'll click the summary. Let's summarize it on the in Leo. Okay, we'll go to summary right here. Agent. Okay, so you're getting close. You're getting very, very, very close. Okay, so you're pretty much in. Okay, so agent. It's very, 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 very PhD in MK Ultra. Okay, Gary Jackson's getting very close. Very, very close. Latin studies. Okay, St. David's Latin studies. No, the guy's a smart guy. Okay, they don't have dumb guys doing this. Okay, I will do a quick summary here. I'm gonna go summarize. Okay, so I'm gonna put on here. Summarize. Okay. I have to put it like this. Okay. Physics or chemistry or science degree. Yeah, but I'm saying what was his PhD on? Yeah, it was like some sort. I think it was a physics degree or something like that. But what was his PhD on? The actual PhD, because you could do a lot of stuff here. Counter intel. Okay, PhD in language studies. Okay, counter intel, rotary motion. That's close enough. I'm giving you the reward. Well, the first guy, 29,000 tons of thermite, got it right. All ballpark. But the closest one is counter intel, PhD in language studies. No, the guy's a smart guy. They don't have dumb guys. Okay. Okay, let's just see the summary. It should show up in a bit. And then okay, let's just play some of this here. There you get some stuff here. Okay.
I did the smart thing, and I took a job as the head of science at a tutoring company where I'd been teaching during my PhD.
Today we're making motors.
And it was a great job. I loved the students and the other teachers.
So wait, go back to his PhD. So again, this is PhD's before, but he says that he was depressed because of his PhD and what he was doing in it. Let's see this.
I got to Australia, I figured I needed to get a job and get some film experience before I could make a decent application. I mean, they weren't just going to accept this Canadian engineer with some ridiculous videos. And on my 6th day in the country, I auditioned for and got a role in this play at the University of Sydney.
All right, St. David's Agent Provocateur. Oh, we're getting close. Yeah, pretty much it, guys. We got nailed it.
And then I started asking around about physics tutoring work, and within a couple weeks, I had enrolled in a PhD in the School of Physics.
So it seems like
So PhD in the School of Physics, okay?
kind of funny place to be in, given that I came here to do film, but
So interesting, he came to do film, but then now he did a PhD in physics, okay?
after a short time I realized how much I still liked learning and how much I liked physics, and I was hoping that I could meld the two, physics and film.
In a PhD about how to make films that actually teach physics. Now, I know that sounds incredibly relevant now, but at the time, it didn't really satisfy either of my passions in physics or film. I know because this is me the night the data first starts coming in from students watching videos that contain misconceptions.
I just think that...
Okay, did you hear what he said? Okay, so you did a PhD on about tutoring, and then he would show videos to students with misconceptions, and then he was getting depressed because he was showing people fake stuff. Let's play it here.
Because this is me the night the data first starts coming in from students watching videos that contain misconceptions.
I just think that, you know, including extra material that is wrong and stuff into multimedia segments is just something that no one's ever going to really put time and energy into, and it's never really going to be worth much, and that sort of pisses me off, and I wish I was doing something a bit more practical.
After I got my PhD...
Did you hear what he just said? Day before the data's coming in his PhD, it really made him mad that he was taking the effort of putting fake info in physics educational videos just to see how people react and believe in it. Okay, that's what his PhD was about making videos like basically making teaching physics through social media or through videos, but it includes what happens when you put fake info inside them. Let's see here.
Film. I know because this is me the night the data first starts coming in from students watching videos that contain misconceptions.
I just think that, you know, including extra material that is wrong and stuff into multimedia segments, including extra material that is wrong and stuff into multimedia segments is just something that no one's ever going to really put time and energy into, and it's never really going to be worth much, and that sort of pisses me off, and I wish I was doing something a bit more practical.
After I got...
all right. So again, this is before he, when he had a conscience, when he was doing this, and he's like, why am I putting fake info in videos? All right, guys, so again, when I first came across this, I'm like, I could not believe this. The person I'm literally calling a disinfo agent, literally making he's literally doing, like, putting disinfo in videos in his PhD just to analyze people's reactions and so on. Anyways, looks like he comes across as harmless and cunning. Looks like Elon's relative, Agent Provocateur. So again, he literally tells you putting wrong info. Who mentored him? That's a good question, actually. That's a good question. Because again, we'll look at up PhD. What's his name? What's his name here? Okay, let's go back to his summary. Okay, so again, we literally came across that. Again, that's bombshell info. Again, everything needs to match according to my hypothesis on reality. Okay, Derek Muller's Journey with Veritasium. Let's see his PhD thesis. Yeah, well, actually, we open up as well. Okay, so again, I'll post this right here. This one is my life story. I'll share this on Telegram. So again, guys, put everything that's related to the stuff I just put it in here. Watch there, and then we'll go to the PhD Muller. Okay, I'll put this as well. This one is the fake gyro, fake physics, just to in case anybody mistakes me for promoting this. Who mentored him? We'll get in that. Again, this board right here is just like when it comes to gyros, it's like absolutely mind-boggling because again, it's, in my opinion, it's as big as 911, in some ways bigger, in some ways much less, which is like practical stuff, but like just directly practical, like it's not advanced tech, but it shows you that reality is so much different than the mainstream. Maybe a Soros or Gates or Schwab group mentor him. Okay, I'm gonna go all this right here. Okay, this is story behind Veritas, a journey pursuing passion. And let's see PhD. See what it says on PhD here. Aim to explore how educating science, yet the concept felt limiting, pushing towards a more practical application in both fields. Unfortunately, despite academic proved fruitless, and so on. I think there was something else. False info. Okay, anyways, probably didn't include that part. Okay, anyways, it didn't come out. Didn't mention that part, but again, that's like only like a tiny segment there. So I watched a video and then that literally like 1 second saying you put false info. So let's go over Derek Muller, PhD. Designing. Okay, there it is. There's his PhD. Muller. Let's go see full PDF. Download PDF. My goodness, I gotta like download for free. Okay, I'll download a script. There should be publications. Okay, there's the full publication. Muller designing effective multimedia for physics education. This is University Sydney 2008. I guess let's download this one. It doesn't just show up. My goodness, where are we? Like, how is everything so hard to find? I guess script might have it. Oh, but this one you might log in. I just want to get one without logging in quickly. Oh, this one might be here. Okay. PhD, and let's just download it. My goodness, just download something. Designing effect. Okay, there's download something. Just work. I'm like opening up. Okay, we found it. We finally got it. Inertia and gyroscope. Extra resources. I'll go to inertial propulsion. Links. Okay, so we downloading this one. Okay, this is some groundbreaking stuff. At least to me. Okay, we're doing live like agent provocateur research. Okay, and it should be in here. Okay, PhD Muller. I'll refresh this. Nudge theory is a concept in behavior economics, decision making, behavioral policy, social psychology, consumer behavior, and related behavioral sciences that proposes adaptive designs of the. Okay, I think that's what it is. I'm going over. I just want to open it up. Where did it go? Just open up. My goodness, it's so hard to find stuff. Links. Oh no, I was in the wrong area. Okay, I'm gonna close this. Okay, links right here. Links right here. Okay, this is Muller PhD. Okay, we're opening it up, and I'm gonna save this area. I think it's this one. I'm gonna save this. Okay, so PhD Muller, designing effective multimedia for physics education. Again, so this PhD was on the thing he's doing right now on YouTube. Dedicated to all teachers who instilled in me the joy of learning, my sisters, and especially Jane, and so on. Okay, declaration of originality, and so on, future multimedia. So again, future multimedia learning. So okay, let's see his supervisor. It should be in there, supervisor. Acknowledgement. My thesis, supervisor Manju Jamara. Manju Jamara. Okay, let's go back here. Who's supervisor? Okay. Obituary. DT India's landscape. Okay, Muller. This is a PhD in Muller. Physics. Let's go physics. Okay, tackling misconceptions in introductory physics. Okay, this is him with the. Okay, that's her. Manjula. Tackling misconceptions in introductory physics using multimedia presentation. This was before his thesis. Reason for this difficulty is not hard. Students come in physics classes ideas. Like, anyways, I'm just gonna sit down. I can keep standing, but I'm gonna go for a run later, so I want my knees to keep having some strength. All right, lower this. So yeah, some fascinating stuff. Okay, we proposed a misconception-based media. Okay, this is all fascinating. Quote above from Wikipedia: Prime Minister David Cameron kicked off a fresh drive for global mind control programs. Cass Sustain and Michael Bloomberg are American pass-throughs for it. Yeah, that sounds about right. Okay. All right, let's see this. Okay, so in 2007, he's talking about misconceptions. Okay, his PhD is literally about misconceptions. So there's his ResearchGate. I'm gonna save this. So that is his supervisor for both theses. So the whole thing was about misconceptions. Our experiments show, however, that exposing students to common so our experiments showing students however show that exposing students to common misconceptions even in non-interactive settings can help them overcome these difficulties. Oh, that's exposing them. Okay, but anyways, but they do show them. We propose that misconception-based multimedia can alert students to key inconsistencies in their reasoning and help tether their own old ideas to new scientifically accurate ones. So, support a conclusion that misconceptions inflict their damage in two ways. They give students a false sense of knowing. So they literally know about people knowing and not knowing, limiting the mental effort they invest in learning. And so as opposed to just tell us the actual truth, okay? Why are you covering up gyroscopes? So again, let's go back here. Let's go back into this. This series summarizes a series of investigations on how multimedia can be designed to promote learning. And then I'll go to the misconceptions. Misconcept. Applications of misconception-based multimedia. Holy, 316 pages this guy's written here. We know the common misconceptions and methods that have shown success in achieving conceptual change in the classroom. How does one handle, if at all, the topic of misconceptions? Battle over misconception. Okay, in which they also invest in more mental effort. Let's see what they do. Can observation of dialogue involving misconceptions be as effective as dietetic? It's basically what they do is they'll show you them stuff that's wrong, and then all of a sudden get them to like buy into it, and then all of a sudden tell them, oh, actually that's wrong or what not. The significant difference between two treatments was that one included only correct scientific information, while the other featured common misconceptions uncovered with a tunneling survey. Okay, so you would show common misconception and then show it afterwards. Expressed by a model student, and they're saying that it's pretty good learning that way. Up from those who viewed more straightforward. Okay, it's basically showing misconception-based dialogue outperformed those who viewed the more straightforward presentation on the post-test. So interesting, showing the misconception. Again, it shows them better in mind control. Yeah, so anyways, so it's pretty fascinating that they literally, Newtonian mechanics multimedia. Newtonian mechanics was selected as a subject matter for the second major iteration of the design experiments. Student misconceptions in this area have been studied for decades and are characterized as internally consistent and robust. Okay, so so they have entire hundreds of pages of misconception science, and then they would give it to people, and then he was getting really upset, saying, "Why am I putting all these fake stuff in the videos?" Anyways, that's mind-boggling stuff. I'll keep that in. And I will save this one here. Okay, this is, again, Veritasium is a wild. Okay, let's go. We have, how much more minutes we have? I want to get up to 12, and I'm going to go for a run outside. All right, so we have 36 minutes, guys. Let's see what else we got. Any of you guys have questions and so on? Castor oil press will help your knees immensely. That or just standing and sitting has helped. Because I just want to save them for my run. I don't want to get too tired, but also standing a lot. I try to alternate 1 hour and no castor oil though. Okay, cold press. So it's like a car. I need to oil my knees. Okay, I'm gonna close some stuff. And also here, for example, you can see my thesis easily. You have to stuff thesis. I did a master's one. I was gonna do a PhD, but then I realized just jump into online mumbo jumbo. Okay, this was a pretty interesting test. So, seepage-induced consolidation. Okay, I like how it shows up right away. And I made this giant thingy. Okay, I made this. I pretty much had to do everything. It was like a one-man show. I had no idea how I was able to construct this equipment, and basically, I would just measure how long things settle down using this these are old sand waste tailings. So I just want to get to the actual nitty gritty. But then I realized, once I realized Hudson effect, anti-gravity free energy, I'm like, my goodness, my whole PhD was a waste. And also, if I knew that electromagnetic fields, like if I interacted with them, I would have definitely tested those on oil sands, and I bet you I would have been able to clean up a whole bunch of stuff. Okay, I think the most satisfying part actually to me was was the science, just the mathematics behind it. These like applied mathematics was pretty next level, and very few people actually grasp it. It's like okay. Anyways, I'm gonna go back to here. Okay, this is elapsed time, lowered pump velocity. I just want to get to the man. How many pages? 148 pages. Okay. But I just want to get to the where's the images of this stuff? Okay, I had to do my own design drawings. I had some images of them. Where's the images? Okay, this was a piston. Okay, I can't believe there's no images. What in the world am I doing? Okay, that was MFT. Where's the actual design? Okay, this is a schematic. Okay, anyways. Holy, yeah, this is a amount of work put into this thing. And that's when I was really, really mad. The gyros made me mad. I'm like, I could have done something like literally defy all physics, and it's so easy. Yet I'm dealing with oil sand waste and so on. Okay, I'm gonna close some stuff. Okay, so anyways, so you guys grasp it, the cover up by guys who literally are professionals in cover up. Like, think about it, they're professionals in fake science. Veritasium, and then he's doing videos out here saying, look, the reason it's hard to lift, I'm like, this is hard to lift because it's heavy. It's not hard to lift because you're holding it sideways. Okay, it's hard to lift because it's heavy. This one, it's impossible to lift anything that far off from the fulcrum. And also, he's lifting it with very little effort. And the whole weight scale thing is a misconception. And also, here's the other part. Imagine Eric Laithwaite knew about gyros lifting on his own. So again, Eric Laithwaite, the anti-gravity guy, did not know that gyros lift on their own. Did not know that gyros lift on their own. Again, gyros lift on their own. I want to go to this part here for those in the setup here. Okay, good evening. Okay, William is in the house, guys. Okay, let's go. Good evening, inmates. Let's go. That's life, but not as you know it. The other part I want to show quickly is that, okay, to make gyros rise fast, I realized how to make it rise faster. And also, if you add weight, it can also go up faster. That's when I realized, I'm like, what's going on here? I add weight and it goes up faster. So, which is pretty cool. I wanted to just demonstrate this here. So added weight goes up faster. So here is added weight. So here I added weight here. This is about 70% of its weight is added in this putty. 52%, and it goes up much faster in this weight scale, this thingy. So it can actually lift and do work beyond its own weight. And this is gonna go lift up. Oh, I know. At this point, the putty actually made contact with it. At this point, the putty made contact with the rotor, and it starts to instantly rise. Let's see what happens here. Why am I taking so long? Okay, there it is. Okay, and it rises instantly. Okay, anyways. And that got me thinking, right here, if you add tape to the rotor, it actually spins and it rises up instantly. And I think I added tape friction added, but I also added weight here. So increasing spin friction makes it go much faster. I will go right here. So, and I also added here to prevent the casing rotation. So here's the, so again, to make gyros rise super fast, it basically losing its spin speed makes it go rise faster. It processes faster and rises faster. Let's play this right here. Okay, so I've been stuck on precession, but we'll get into the actual like linear propulsion. I haven't got that well. Okay. So here, I added tape on top. You can see the tape, it's like spinning it around here. It's on the edge. So it's losing its spin speed much faster, but look how fast it rises. It rises in a minute, as before it was 7 minutes. Okay, there it is. 1 minute, 13 seconds. And falls down roughly, violently down. Okay, so that was that, and then let's go back to the propulsion. Anyways, so I want to stress that enough. Just precession itself is propulsion. It's a circular propulsion. So here is Eric Flaithwaite's demonstration here. I should download all these videos. Okay, this one here, gyroscopic propulsion. This was at the 20. I had some issues with all the things that all got shrunk. 2311. Let's go 2311.
My lies. Indeed.
I feel that the establishment will not accept anything unless we've differentiated it twice.
A retired government engineer,
The spinning...
precessing gyro.
We cracked it.
Okay, camera running. Ready?
Hang on. Ready?
Why isn't it showing? Okay, there it is.
Okay, camera running.
Okay, so watch what happens here.
Ready?
Hang on.
So what he has is he has all the weights on one side here, and he cuts off he cuts off the or burns off the string that's holding these two, and then they're gonna start processing without the expected inertia. Or move forward.
Ready?
And then launch forward.
2 gyroscopes.
Okay, so basically what he's doing is this part right here. Okay, again, I had some issues with my. I need to update all these. I had images with my Google. My Microsoft Word automatically compressed everything, and then when I was before I put them on the Hive blockchain. So here's the center of mass is all these weights, and then the center mass moves all the way here, but this thing only shifts a tiny bit. So center mass is moved completely over to this side, and so in other words, the mass is transferred. Okay, and then so that's illustration of that. Again, it's all down to this thing. This thing is the simplest thing of all time. Okay, I'm gonna go back to I think, and I'm gonna go back. Yeah, so then he describes it here and so on, and even but this is that toy one. But now let's go over some practical ones, and the practical ones is from this pretty cool website. And again, this professor is doing mainstream stuff, but what I like about him is that he tells you directly gyroscopes are the hardest in all of physics. Okay, angular momentum gyroscopes are the hardest in all of physics. It's most counterintuitive because again they don't teach you properly because there's something going on in the ether behind it. Okay, I'm gonna go over to the gyro setup here. Okay, I want to go to. I'm gonna dive into inertial propulsion. I'm almost there. Again, this is a 22-hour long video. All these notes I put them on the Hive blockchain. Going back into this part here. Oh, okay. Anyways, I'm almost there. We have a few minutes. We have 26 minutes left. I just want to get to some devices, and I do want to upload some of the guys' videos, but later on. Again, I have a lot of stuff on my plate. Okay, there's a torque over unity stuff, and I want to get to the propulsion stuff. Okay, where's the propulsion? Where is the guy's name? My goodness, how much videos did I make? Or I'm not sure how much. Okay, I just want to go over to these guys. Okay, Whoopee Jump is the best one I've seen. The most clearest videos.
Good evening, ladies and gentlemen.
Okay.
This is Whoopi speaking, and for tonight we will present the part 21 of my inertial propulsion with gyroscope. So, as in the part 20, I use this system. Okay.
Okay, so basically what happened is there's precession, and then he forces it, and forced precession just makes it rise. In this case, go forward.
Is now working. I will wait.
No, notice how it's launching forward. This is
until
amazing.
The gyro got their maximum speed. Of course, I have changed nothing. You can see here.
So in this case, you got to make it a tiny bit incline so that it does extra work.
The table is timing. Okay. Okay, let's go. Bing.
And it's pushing the remote.
Bing.
Oh, yeah.
Incredible, isn't it? Bing. Okay, let's go back here.
So again, with gyros, on Earth it just looks like a little toy, but in space at least you can move around. Yeah, so they probably definitely have this in space stations, assuming space is real. So
not only the system is climbing up the hill, but it is pushing away.
Oh, uphill. I think he made it slightly. Did he make it slightly inclined? No, it's not uphill. So it's pushing the weight forward. Okay, this is again irrefutable. Whoopi, you're a magician. Keep up the great work. This was 6 years ago. Let's go, guys. Again, this is all old stuff. And I think the last one, the ultrasonic propulsion. Ultrasonic propulsion. What does this one do? Cavity and screwdriver. I think he did a bunch of cool stuff here. Okay, I want to see some other stuff. He made one rotating sideways. This is he has some other cool stuff. I just want to go back to inertial propulsion with gyroscope. Motorizing the gyro, popular. Where's the types here? Okay, this is producing work 1. Yeah, well, this was the best one. He has some other prototypes. Part 20, forced precession. Now this was, when was this? This was 6 years ago. This was 6 years ago as well. Oh, I think this was the that other guy's experiment. Okay, and there's another one rowing the boat. He's literally rowing the boat of the ether. Let's play this one. Play these. What do we got?
Good afternoon, ladies and gentlemen.
Ultrasonic precession.
And if we could press. Okay, now I will put the power on, and we see the vapor will go this way, and there is probably propulsion on the other direction. Let's try.
Okay, ultrasonic vapor vibrating there. Okay, so that's ultrasonic vapor.
And yet, as you can see, it works. It is quite strong.
Okay, that's ultrasonic stuff. Ultrasonic cavitation. Okay, that's interesting. Okay, so anyways,
Good evening, ladies and gentlemen. This is Whoopi speaking. Elevating, precessing, and then down. Okay.
Okay.
Ladies and gentlemen, this is Whoopi speaking.
Okay, I think it's a Viella one here.
And tonight we will speak of inertial propulsion with a gyroscope.
Yeah, so this is the exact same one that Harvey Viella was doing. Oh, I need
You
to
can
say
see it moves. I will explain after.
Yeah, that is the exact one. Hey, I'll tell it right here. I'm gonna summarize as well. This is fascinating stuff, guys. To me, at least. Okay, so also, yeah, before I get into more of the testicle stuff, I need to figure out how to do a Faraday cage. I think I'll do that next live stream, and also get an oscilloscope. I'm gonna post this right here, and I will send an email out to John Hutchinson's friend Alec. What is all these stuff here? Okay. Alec. I sent it to Alec. Okay. Yeah. Made a working prototype. Or I'll say this channel. Okay, let's put that there, send it to him. Yeah, I completely forgot he made it. Again, I've covered it so long ago, but it's been a while. But so basically, it processes, and then once it goes over to this high part, this hits the ramp, and then this torques down, and then this starts rolling on the back end. Yeah, see, right when it. Okay, let's go back here. I'm gonna open up the. Where's that? Did I have that email? Okay, let's go back into the. I'm gonna close some stuff. I'm gonna close. Let's go back into. I'm gonna close. Yeah, this part right here. So, right when it. So initially, this is a support ring, and it's going this way. So then, if the wheel's on this side, like once this gets on a support ring, this will start rolling this way, and it will start processing it or forcing it this way. In other words, it's gonna start rolling. So going back into Whoopi jumps. So this back end right here, once it touches, or once yeah, so he has like this roller or this bearing on top here, and this is tilted up. So once it hits it, it starts this starts pushing it down, and now the back axle will hit the traction ring, and it will start rolling. So then the whole thing is going to roll, not process, roll. Once it goes off the cliff, it starts processing. Yeah, there it is.
Okay.
Yeah, so the faster part is when it's it goes faster when it's rolling. And
Okay.
right here, I'll go back here. Slow motion. So this thing here, it's gonna hit it. So look at that, right when it hits. Yeah, so right now it's hovering, so it's floating. It's hovering, it's processing, and now it's going off a ramp. It's going off. These are both ramps. Actually, yeah, you don't need to target. It just hits it. Yeah. So now there's a ramp, and now it hits this, and this one is just a support ring actually. Yeah. So then this would, yeah, actually this one is there. Let's see, the support ring. I think the support ring is just so it doesn't go down. It just so it still rolls again. So that's not as important. This one's an important one. As long as this one it's hovering. It's processing, and then once it hits here, it starts rolling. Now it's gonna force faster. And now and it's still forcing it, and right when this gets off it, it's processing. Now it's no notice how it flies. So notice the part right here. This is pushing it, and then it gets off, and now it's flying. Processing and then roll.
Very well. You can see now if it can cause on the other side. We turn the machine on the other side. We have to push it some. Voilà. And if it goes on the other side, there is no slope. And it works.
Yeah. John says, 29,000 tons thermite. Yeah, don't kill yourself. Just listen to John. Yeah, for sure. Just, safety first.
Very, very interesting, isn't it? Okay, now I will explain you. You stop the machine. Oh.
And then he tells you right here when it touches it.
Very, very good patent about inertial propulsion with gyroscope.
So again, a lot of these things, they're little. I think because you're not going to get it in space. In other words, NASA's not going to let it do that. So it's like you have to, when you design stuff, focus on the here and now. How do we get stuff out of it now? Because no one's gonna take us up space unless you have some funding for that. But even then, you get sabotaged by some agents. So this is where the key part is. I want to tell everybody: precession is inertial propulsion. Precession is inertial propulsion. Okay, there's no ifs, ands, or buts. Anyway, so here's a cool one. It's like paddling the ether.
Ladies and gentlemen, and tonight we will make the part 10 of this video series with a double gyroscope system. On each side of the engine you have the transmission, okay? To regulate the speed of the engine, I have to help sometimes because it's not very powerful.
Okay, spinning them up.
Okay, and we'll wait. And as you can see, it starts from itself. No need to push.
Yeah, so basically what he does is he pulls it back and then lets go. Pulls it back and processing. It arrives back on precession. I think it does start moving a bit. Yeah, so it's like
and
literally
it works
rolling.
Really, really well. Okay, now I am at the end of the table. I have to stop. Let's get it for a second. One. You see the gyro are working exactly in synchronization. It is not perfect, but it works well. Okay.
Okay, so that's pretty fascinating. I think I made a diagram on it. Again, it's been a while since I did a diagram on it. Okay, I think it's... Oh, this one, I have it upside down. Okay, this one is the same one. Yeah, this is the same wheel as that other one. Okay, I'm going to go back to this one. I think he has this one, part 9. Okay, see, he has a whole bunch of types here. This guy's on another power level.
Ladies and gentlemen, and why we are...
Why is it upside down? Oh my god, okay.
Idea is to make a twin system.
Oh no, this one is the rotating back. Okay, so this one is it processes torque back. It is the exact same thing as before. So it would spin this way. It's processing. I think he force processing to stop and reset. That's magically propelling the gyroscope forward. Let's go. Yeah, you're basically pushing it against its own self so that it pretty much like you're stopping the precession. All the weight comes back and then it goes. Anyways, it's exactly the same thing here. But I gotta fix up these diagrams. I'll do that later. Okay, I think I think I should fix hinder through a sloped ramp and so on. Okay, that's close enough. Actually, I'll maybe change it maybe later. I do want to see the Whoopi one. He had a paddling. Okay. I think I had one. Okay, I didn't cover this one in that thingy, but I didn't make a diagram of it. But anyways, this is pretty cool.
Okay, thanks for watching, and
okay. So let's go here. Okay, so we have 14 minutes. Let's see what else we can cover in here. I think there was a few other stuff that I had in my thought experiments. Okay, there was the something about rising faster. Okay, so anyways, I lost my train of thought. Anyways, I'm gonna start closing stuff. Hopefully get my train of thought. You know, actually, these valued thing. I'm gonna Google it right now quickly. Let's go into. Okay, I'm gonna Google UK BitChute. See what happened with the UK and BitChute. Okay, UK discontinues video hosting. Okay, Day Skeptic. Holy. Yeah, this is absolutely insane. UK regulation. Okay. To our valued UK, after careful review and ongoing evaluation of the regulatory landscape in the UK, we regret to inform you that BitChute will be discontinuing its video sharing service for UK. So, like, what in the world's going on here? Yeah, notably the act. Yeah, so basically, the UK Online Safety Act of 2023 has brought about significant changes in the regulatory framework governing online content and community interactions. Notably, the act contains sweeping provisions and onerous corrective measures with respect to content moderation and enforcement. In particular, the broad enforcement powers granted to the regulator of communication services. Ofcom have raised concerns regarding the open-ended and unpredictable nature of regulatory compliance for our platform. Has always operated on principles of free speech. Therefore, anyways. However, the evolving regulatory pressures, including strict enforcement mechanisms and potential liabilities, have created an operational landscape in which continuing to serve the UK market expose our company to unacceptable legal and compliance risks and so on, despite our best efforts to navigate, so they can't do that. Therefore, immediately, BitChute platforms users in the UK will no longer be available to view content produced by... no, these are BitChute platforms in the UK. Yeah, so you can't view anyone... So you can't view any BitChute content if you're in the UK unless you use a VPN. So again, VPN important. Because the OSA primarily focuses on members of the public will view content deemed unsafe, however, we will permit UK BitChute users to continue to post content. Interesting. So you can post content, but you just can't watch it. Holy. Not be viewable by any other UK users, but will be visible to anyone outside. Users outside the UK may comment a comment, which your creator will continue to be able to read, delete, block, reply. So the UK guy can view it, but can you view your own one? Continuing to post content. So you might be able to view your own one, I think. Or, yeah, you can view your own one, but you can't view when you're not signed in then. Users outside the UK may share UK user-produced content to other users outside the UK as normal. In other words, users outside the UK may share UK user-produced content to other as normal. In other words, for users in the UK, including content creators, the BitChute platform is no longer user to UK user video sharing. Okay, so this is absolutely nasty. But at least you can still post there. So BitChute has literally lost this. Gone. Okay, gone. So again, we're in a society where we have technology to overcome these. So you have to start using them. It's going to be a bit of a hassle early on because it's not as streamlined and efficient as the other ones. But at least as a backup, you're gonna have to. And the more you use alternative platforms that are free speech friendly, the more money they get. The more just the network effect they get, so the just stronger it gets. So in other words, for example here, Hive cease and desist. So BitChute is scared of legal stuff and lawsuits and government regulation and blah, blah, blah. So cease and desist. So this is wait, cease and desist. Yeah. So anyways, so if you go just to illustrate what I mean by like on decentralized platforms. So when Hive was created as a fork of Steam, the Hive blockchain company, they requested cease and desist from the new Steam community hard forked using same name Hive. So they issued a cease and desist letter, but there's no one to sue. So it's like, who do you? They issued a letter, and this is in 2020. So Vancouver Hive Blockchain Technologies company, or Hive, has announced that its legal representation has requested a new blockchain cease and desist using the name Hive and Hive Blockchain for its new hard fork of the Steam blockchain. So in response to multiple shareholder inquiries, so shareholders telling, yo, sue them, and they're like, well, sue who? So again, 2020, they're doing a cease and desist, yet nothing happens because there's nothing happening. Like Hive.io. Hive.io, it's decentralized to the point where no one runs, like no one person runs anything. And you can see all the witnesses. So on Hive, on the Hive blockchain, these are all the block producers where they get paid from the Hive inflation to the token when basically they get paid. Yeah, they get paid in the Hive token whenever they produce that block, or they get all the transactions, put them on, and the top 20 get the most money, and then afterwards, and then basically there needs to be consensus between top 20 plus an extra one, I think randomly picked. But anyways, there's a mechanism, and then those in the below ones, they randomly get some tokens or some money as well. And I think there's let's say 100. So if anyone gets taken down, for example, let's say this person here is in UK and they don't want witnesses. Oh, and let's say that he's not anonymous, because some of them could be anonymous. You don't know them. All you have is your reputation. But let's say UK finds out one of these guys is running a Hive witness server. So then what they'll do is like, hey, they'll kick this guy out, or they'll take his computer and block him. But then this other person takes a spot, and then everyone just shifts over. And then basically, and then you have like 100 different people. Anyone's ready to take in, and then they'll get all the money and so on. A lot of people are here. A lot of witnesses. Okay, and then some of them don't update and so on. The ones at the very bottom, but then as a higher and higher it goes. And let's see. Let's see how much Hive witnesses, Hive witness revenue, witnesses revenue. How much they make? And I think the top ones make about $2,000 a month, monthly earnings. This is December 1st, 2020, and this is Hive.blog. I'll switch over to Peaked. I like Peaked better. Okay, so again, you just change the front end. So all the data is on the blockchain. So what do they do? Let's see the earnings. Okay, this is earnings. This is as of December 1st. And so this one's earning 12,000 Hive, almost 12,000 Hive per month. And then there's, again. So these guys put it, basically they have a server. They put out the block on, and they host it all. And basically, all these guys are hosting all the data, and to make sure it's all in sync, and so on. And again, so there's no one to sue. So you can go after one person, another person will take over. So no one, and it all over the world. So you're gonna have to take over someone in Cameroon, someone in Nigeria, someone in US, someone in UK, someone in whatever. So again, that's where we have to move to. But it's also, again, I think all part of the plan, making governments irrelevant. Eventually, governments will be part of a network state. Like be all digitized governments. They first got rid of chat, and now gone. Interesting, chat's gone as well. Or chat what? I think they have chat on BitChute, don't they? Let's go to BitChute. Anyways, we have 6 minutes left. I'm just rambling random stuff until yeah, UK prisoners. Yeah, I think they had stuff. Let's just click here. Rome crashed. America next. So again, really great.
Watch how
I hate that.
There's Grace here.
There's no chat. Yeah, there used to be a chat there, or at least mine has a chat. Anyway, really graceful, knows about 9/11, keeps it to herself, so that's pretty interesting. Very interesting indeed. And let's see, there should be a chat somewhere here. Okay, they got rid of the chat, yeah, for sure.
How people in
I hate how you.
Now let's go over and.
Yeah, you have to click. Okay, there was no chat anymore. Again, there's no more chat. Didn't you do a stream about Hive 4 weeks ago? I did something like that. I did a I did one about blockchain. I didn't think I did one about Hive. But anyways, guys, get on Hive, and we're gonna have 6 minutes, and but yeah, definitely get post anything important. Text form again. It's like the most important. It's like the only decentralized one, but also for AI, the importance of it, where you're gonna have all their data stored on the Hive blockchain. You know everything is not tinkered with, and you could, if it is tinkered, you could check it out. And the thing is, if data on Hive gets tinkered or the it becomes centralized or anyway, everyone's just gonna leave or fork from it. So that's the thing. It's one of those where if it gets tinkered, it's gone. But at least you'll still have 100 people with all the data, and you can go and take at least that data and do your own stuff with it. Anyways, I'm gonna close some stuff. What else do we have here? Again, this is Eric Lightweight, anti-gravity wheel, and I think so. Anyways, this guy's stuff is pretty cool. But yeah, with gyroscopes, pretty much like that. But I think the real practical use is in the torque over unity. And I could have sworn I saw a video before someone claimed to I think Iranian guy claimed to have made a free energy device using precession, because I think precession is the key for practical gyro free energy or torque over unity. So again, going back over to the torque over unity. Torque unity. Or okay, torque over unity. And this video is gone as well. Okay, so I think I have the last footage of this from my channel. This was the Francis McCabe one. Okay, so this is a 1,000-pound wheel. If you haven't seen it, again, I can't stress it enough. Like, it's like I've semi done my part, which is I've made this so clear. But now I do need it. If I had a lab technician and somehow make a practical device here. So for those in a gyro propulsion setup, if you are good with gyroscopes, if you can focus on torque over unity device, somehow go and lift the car up with using a tiny motor, because it is possible with gyros, and the key is forced precession. So for example, if you have a motor that has a 1.25 inch-pounds of torque, it can power 1,000 pound and a 1,250 inch-pound torque output. So this is 1,000 torque over unity. So for example, if you had a motor 1 inch pound of force or torque, it can rotate a 1 pound wheel 1 inch away horizontally. And 1,000 pounds of inch torque would be 1,000 pounds 1 inch away. So this same motor can power this if it's in precession. If you hold it fixed, this one will not be able to spin it. But if it's spinning, then it precesses on its own. It's lifting. It's literally levitating on its own. So for example, if you had a motor that can only spin a wheel, it can spin a motorcycle if it's precessing. If you allow it to precess, that's what I'm trying to say. So in other words, you could use a motor that is powered by you spinning a wheel, can spin a motorcycle that's allowed to precess. So this one is fixed in place, but if it's allowed to precess, that's when gyros do its magic. The whole thing is precession. Precession is magic, in my humble opinion. And then so you can torque it and move it around. So now if this is moving around, and then you connect this to some sort of other generator, you can actually turn like a giant generator. And this was a giant piston this guy was able to do with, I think I made, how much torque over unity was that? And so basically he had two wheels like this, spinning, and then so these are two spinning, and then he would force on the, make it precess the, or just basically torque it opposite direction, and then that somehow generates a giant force there. So that's the key part there. So you can literally have a piston there that's massive. And again, to illustrate how powerful these are, you go to the 10-minute 40-second mark of this right here. So gyros, they behave massless sometimes and then behave powerful other times. And that's the key part. I want to, again, a lot of this stuff takes time, and then while I'm dealing with the John Hutchison stuff, because that I think is time sensitive, because John is not here for forever. 10:40. Okay.
And no centrifugal force.
Yeah, so no centrifugal force, very little. It's nothing going laterally. No jerky motion. It's going smoothly. But then once he has a rubber piece on the engine, once it touches this, it starts violently shaking the whole entire table.
Let's wind it up.
So he winds it up. So in other words, he's force precessing it, so it rises. He's just torquing it sideways so it goes up. And then once it touches the top glass, it's going to start rolling. In other words, force precessing even faster. And look, touch it goes. And look, it shakes the entire table. A little tiny wheel relative to the giant table. It's force pressing and wants to go up, but there's nowhere to go up, so it's just going to be pushing.
Bring it down off the ceiling. Whoa, steady boy.
It actually knocks over the glass.
Go silent as a lamb.
I think he does it again.
Now surely at the lower, can he climb up on his own? Can he climb up on his own?
Yeah, so basically what he's showing is that it climbs up on its own because it's force processing. This is at an incline. It rises up.
Once more.
But yeah, his gyros are so powerful, it's ridiculous. Okay. But he was torquing it the opposite way. Opposite way goes down.
Yes.
So right when it touches it, it's rolling up as well because force position rises. And it actually knocks over
He can climb as well as fall. Whoa, he's lifting the whole lot up.
Okay, so anyways, knocks over the glass, or the plexiglass. Okay, so basically, rolling, it rolls, and then force possession causes lift. Force possession causes lift, and so on. And I actually have this this one right here. I actually made a little motor. I think where's the video? Oh, this was unlisted. I should publish this maybe. This is I literally put a battery 91 grams. Yeah, 129 grams on the top, and it rises. I should upload this one actually. Let's just I think I'll do that. Yeah, maybe after the Hudson effect ones. I'm gonna go over to this one. Okay, I think it's unlisted. Let's go battery. I'm gonna go to MES on my dashboard. Quickly find this. Again, so basically the whole thing I'm trying to say is use a keen eye on a lot of this. This is where mathematics comes in. Just it helps with logic, like looking at a symbol and then seeing what it actually means. It's similar with science, looking at what it actually means, and not just looking at the big picture, looking at the small picture sometimes. Okay, I'm gonna go to battery. Okay, this was battery mounted. Okay, I'm gonna go over what was the title of this one because I didn't put a link for some reason. Okay, I'm gonna go over to the battery. Where did it go? Where am I even at? Okay, so I had a battery somewhere. Yeah, this one. Okay, this part right here. This is battery mounted spinning top. Battery mounted spinning top rises in 0.04. Okay, let's see which one is which one. Spinning battery mounted rises instantly, falls. Where's the better one? Battery mounted draft. Battery mounted. My goodness, what is the thingy? Okay, rises in. I need to find this one. Where is this one? Why is there no link? Battery mounted top rises in. Yeah, spinning top rises. Okay, which one is this one? Did I change the title? Okay, this is getting annoying. Okay, this is 146. 146, 146. This one is it. Okay, rises. Okay, this is 100. This is unlisted. It was on my drafted setup. Just play the video, my goodness. Yeah, I think I might upload this one. If it's a good quality, let's see how this is. So 129 pounds percent of its weight is on the top. So basically, spinning top is 70.28 grams. The battery is 91.30. Or the battery on top of the whole setup. So anyways, amazing stuff. And when spinning tops, mainstream says, oh, it's rising as it's rolling or something. But again, gyros rise without rolling. So it's like, nope, it's because it's anti-gravity. It's my whole opinion. And okay, anyways, there's that. And yeah, I think it's 12 hours. Okay, it's 12 o'clock, guys. I'm going to go and do my thing. Okay, guys. And someone had a comment earlier, but Veritas, it's removed. But anyways, no worries. Send me a message and so on. Okay, and some other stuff. Okay, this is fascinating stuff here. I'm gonna close this. Okay. Again, there's infinite amount of info, and then the key is, yeah, another key thing is how do we select stuff based on, like when there's infinite info. How do you pick and choose which one? And that's where it uses discretion and logic and other mumbo jumbo. Anyways, guys, I'm just mumbling, and I'm gonna close this. Okay, that's all for today, guys. Okay, this one is live chat. Why does this say need to do a strategy session? This is way late. Okay, this is way late. Let's see, we had 11 people. We had a decent stream, guys. Thanks for joining. Let's see what else we had here. I'm gonna click on. Yeah, amazing stuff. Yeah, thanks 29,000 tons, and also, yeah, thanks for your work as well, and also the intro and other stuff. All right, thanks for joining. Have a great day. Okay, what's topic on Saturday? Saturday, it's gonna be a solo stream. I'll do random stuff. I'm not sure what we're gonna go over. So, anyways, yeah, what do you think I should do? It? Let me know. But next week after, the week after, on the 19th, that's gonna be Methyl Miner's gonna show up, and he's gonna do a he's gonna talk about psychedelics. Apparently, his bicycle day, psychedelic day is on April 19th. That's gonna be quite wild. But this Saturday I'll do a solo stream. Basically review what we did and just see what's happening in the news and see what we can cover. And also my 9/11 stuff. I have some stuff I'm working on. Why isn't it just showing? My goodness, nothing's working. Anyways, guys, that's all for today. Thanks for watching, and stay tuned for another Math Easy Solutions. I'm gonna go end stream. Ending in 3, 2, 1.